let's quickly revise what we have learned so far. So to put it in a very simple words, you should see gravitational lensing as a coordinate transformation. So if I take the source to be here, lens to be here, and then instead of traveling in a straight line, the light ray bends at this point and then it reaches us. So we call beta plane or the beta 1, beta 2 as the coordinate frame in the source plane, and theta 1, theta 2 as the coordinate frame in the lens plane. And what lensing does is to take a point in beta and map it onto a point in theta space. So in other words, I can draw, so this plane is going into the board. Now I am just drawing it as if it is the plane of the board. So theta 1, theta 2, and beta 1, beta 2 are the x and y axis, but for the different planes. So this is what we call as the source plane, and this is what we call as the image plane. They are just two parallel planes, but then their coordinates or their axes are different. That's why we call them as beta 1, beta 2 and theta 1, theta 2. And what lensing does is to take a point in the source plane and map it onto a point in the image plane. For example, it could, I'm just drawing two different points. So this would mean taking a point here and mapping it onto a point here, and taking a different point here, mapping it onto a different point here. And A is this matrix that tells you how to go from one point in beta to its corresponding point in theta. So this is given by A, and the inverse mapping will be given by the inverse of A, which is just the A inverse. Yes. Is this clear? Yes, that's what I was thinking. Yes, so A takes from the theta plane to the source plane or the image plane to the source plane, and A inverse is what takes from source plane to image plane. You are correct. And this is assuming that the mapping is sufficiently smooth, invertible and so on, which can fail for strong lensing cases, but excuse me.
Shall we have links together?